Hello everyone. Good morning. Welcome to Ganit. I'm back with some questions today. We have done the concepts related to the chord properties, the angle properties, the arc properties. So all the concepts related to the circles, pretty much for grade ninth at least, uh, as well as grade 10th, some of it, because we have not covered the tangent properties and all those things. So tangent properties is basically and intersecting chords is basically grade 10th. We'll talk about it a little later. For now, I want to solidify all the concepts that we have done so far, and we are going to start with some practice questions now. Okay, guys? So let me start with the diagram for this question first. So two circles of radii 17 and 25 centimeters. So there are two circles here and they are going to intersect each other. They're saying at A and B, so we'll mark this as A and B. If the length of the common chord is, guys, basically a chord which is applicable to both the circles. Okay, so this is the chord they are talking about. The radius has been given as 17 centimeter and 25 centimeter. So because of the chord properties, we can easily say that this is perpendicular. And this entire chord, which was 30 centimeter originally, can be 15 and 15 divided into two equal halves. So I'm just going to use Pythagoras theorem. Let's just call this center as O, this as O dash. The question says find the distance between the center of the circles. So they are asking us to find the value of O dash, which is quite straightforward. We have this triangle, we will apply Pythagoras theorem. So 17 is the hypotenuse. If I mark this point as P, so I can directly find OP square by doing 17 square minus 15 square, which is 289 minus 225, which is 64. So OP will be equals to 8 centimeter. Then if we look at triangle O dash AP, the right side triangle, O dash P will be 25 square minus 15 square, which is 625 minus 225, which is 400, is O dash P square. So O dash P will be equals to 20 centimeter. Therefore, OO dash is equals to 20 plus 8, 28 centimeter. So the trick, the difficult part about this question was to figure out the common tangent part in your diagram. And usually in questions like this, they will not give you the diagram so that, so you have to kind of figure out what the diagram looks like. Okay. So this is how we do this question. Let's move to the next one. This is a good question. They have said that the values of PR and RQ are both 8 and 8. That means this is 8, this is 8. They've also said RB is 4. So this part is 4. What I'm going to do is I'm going to assume OR as X. So the question says the AB is bisecting the chord PQ. So that means PQ entirely was 16 centimeter. If you see 8 and 8, and that's the question. They are asking you to find the value of the radius. So I'm just going to join this. So they are asking us to find the value of radius. Now, the trick in this question is, if you notice, OB is the radius and therefore it should be x plus 4, OR plus RB. But don't you think OQ is also the radius? And one circle cannot have two different radii. So precisely, the OQ also needs to be x plus 4. So what we are going to do is we are going to apply Pythagoras theorem. So we can write OQ whole square is equals to x square plus 8 square. And what's the value of OQ? X plus 4. So this becomes x plus 4 whole square. Remember, guys, don't write x square plus 16, x plus 4 whole square. Follow the steps, you will never go wrong. Okay, if you try to skip the steps, there is a good chance that you might make some silly mistake. Be careful, write it as x plus 4 whole square. Then you should also be able to see a plus b whole square into the game. Okay, this is equals to x square plus 64. I'll expand it. I'll get x square plus 16 plus 8x is equals to x square plus 64. X square cancels. I have 8x is equals to 48. I'll take the 16 that side. I'll get x is equals to 6. Remember, a lot of times while doing a question, we have this mindset that if I have found x, we are, see, in India, we mostly learn algebra in the first half of our mathematical journey. So it's mostly finding x, y, finding the age of a father, finding the side of a triangle. There is so much finding that we do that almost we believe that if I have found x, I found the answer. A lot of times that can go wrong, especially after grade 9th. So if you have found x, please hold on for 10 seconds more. Figure out what is the question really asking. The question was asking you the radius value. X is not the radius. It's not. The radius is x plus 4. So what we will do, radius is equals to x plus 4 is equals to 6 plus 4, which is 10 centimeter. So this is how you do the question where one part of the radius is given, this 4 here. This was the trick. So if you were able to notice that OB is also the radius same as OQ or OP, then you would easily solve this question. It's not really that difficult to. Okay. All right. Let's move to the next question. All right. What do we have here? So we have a pentagon, A, B, C, D, E. We also have A, B, B, C, and C, D as equal to each other. So I'm just going to mark that diagram, mark that thing on the diagram. A, B, B, C, and C, D are equal to each other. We have ABC is equals to 130 degree. So this whole angle is 130 degree. Okay. Now, if you remember, I had told you in one of the theorem videos that if you have equal chords, they make equal angle at the circumference. This theorem, remember? So we are going to use that directly in this question. So if you see, AB is an equal arc to BC and CD. So this means this angle should be X, this angle should be X, and this angle should be X. Guys, please remember, you never let the angle stay as angle AEB or angle BEC. No. If you know that these angles are all going to be equal eventually, please use your inherent mathematical ability, which you are comfortable with. Bring X and Y into the question. Rest, everything will take care of itself. All right. So let's talk about this. Now, it's one very important thing in this question is the use of cyclic quadrilateral. So if you see, sorry, ABCE is a cyclic quadrilateral. A, B, C, E. Four sides, all four vertices on the circumference. So it's a cyclic quadrilateral. Now, when we have 130-degree angle at B, shouldn't angle E be 50 degree? The angles of a cyclic quadrilateral, they add up to 180 opposite angles. So I will write the reason here. ABC is cyclic. Therefore, angle B plus angle E should be 180 degree. Therefore, 130 plus angle E is 180. And from there, you will get this. Angle E is equals to 50 degree. But angle E is also X plus X. If you notice, right? So that means 2x is equals to 50 degree. That means x is equals to 25 degrees. Let's talk about the question now. I did all that without actually thinking about the question. Now we will think about the question. So it says find the value of AEB. So where is AEB? I think AEB is x only. So I have figured out the value of AEB. What is AED? That means 3 times. So angle AED is precisely 3x. If you see 1, 2, 3, all three are x. So that means 3 times 25, which is 75 degrees. This is how you solve this question, guys. Okay. All right. So I hope you have understood these 3 examples. We are going to move to the 4th one now. Okay. Okay. That looks quite straightforward, quite normal. So we have arc AB is twice arc BC. Okay, so this is one thing you need to know about. So if you have a circle and if you have these 2 arcs, making some sort of angle at the center, and the question says that this arc is twice this arc. That means the angle subtended by this arc at the center will also be twice the angle subtended by that arc. Okay, so basically the rule says that angles made by the arc follow the same ratio as their arc length. So if I had to say that one of the arcs is 3 times the other arc, then I would also have to know that the angle made by that arc will be 3 times the angle made at the by the smaller arc. Okay, so they just go with that same ratio. All right, so the question says arc AB is twice arc BC. So angle at AB made by AB will twice be the angle made by BC. So if I am assuming this as x, it becomes 2x. Now they have said angle AOB is 80 degrees. So that makes our life easier. So we have 2x is equals to 80 degrees. That means x is equals to 40 degrees. Okay. So I hope you have understood this part. So BOC, which also happens to be x, is basically 40 degrees. Now it's turn to find angle OAC. Now again, triangle OAC, can we say that OA and OC are equal? They are both radii, correct? That means uh, angle A plus angle C plus angle AOC should all be 180 degree. What is angle AOC? 3x. If you see, this part is 2x, this part is x. So 3x, and what is the value of x? That is 40 degrees. So that means this basically becomes 3 times 40 degrees, which is 120 degrees, and angle A plus angle C, which by the way are both equal. Okay, so we can say twice angle A plus 120 degree is equals to 180 degrees, and that's how we get angle A is equals to 30 degrees. Angle A is nothing but angle OAC, guys. Okay, so I hope this is clear. This theorem is very important. This is a very important rule. The arc lengths pretty much go hand in hand with the angles they make at the center. So if you know that, this question should be okay. All right. So we'll catch up in the next class, guys, for 2 more questions, I think. Good questions. And probably from there on, we will pick up the um, chord properties, which intersecting chord properties and the tangent properties of the circles. My plan is to finish circles of grade 10th right after grade 9th, so that you can, so whenever you have this compilation with you, and you're getting stuck with something in grade 10 circles, you can always refer back the grade 9 circle theorems. Okay. All right, guys. See you later. Have a good day.